Hello and welcome. On the bench today I have a Gigabyte Socket 370's GA6W-MM7 board. This was sent by one of the viewers of this channel, Adrian. Thank you very much, Adrian, for sending the board. We've seen one of Adrian's boards before. It was the Acer V58. I think there were a couple of episodes, so if you're interested, just go back and have a look. It was an interesting repair. The reason why Adrian sent his board is that apparently the CMOS battery gets depleted very, very quickly. So today we're going to see whether we can fix this, and we're going to compare it with a random motherboard that I found in my stash. This is Socket 1. It's an Asus P2L97, mostly because I have no idea how much current is being drawn by the battery when a motherboard is idle. So let me thank today's sponsor, PCBWay, and now let's start working on this Gigabyte motherboard. Now, the Gigabyte GA6W-MM7, according to the RetroWeb, is an Intel 810 chipset for Intel 370 CPUs. It supports up to 512 megabytes of SD RAM and has an FSP up to 100 megahertz, so I should have some RAM available. I think this is probably 133. I think as a starting point, I'd like to power it up. I never powered up this board, and I understand it works. I just would like to see it working, hopefully before and after. Let me confirm that the battery I received with the motherboard is actually depleted. And yes, it's reading actually negative voltage for whatever reason. It should be the proper polarity, but it's reading 0.018. Now, if I do the same with the Asus, which has been in the box for quite a few months, I mean, it's reading 3 volts, so this is totally fine. And again, batteries are supposed to last for many years, even though the motherboard is not being used. Now, I don't really know how the CMOS battery works. I'd imagine that when there is no power, well, obviously the battery is responsible for keeping alive the settings of the motherboard 100%, but when the motherboard is powered on, or maybe even when the motherboard is in standby with the 5 volt standby coming to the motherboard, well, then I'd imagine the battery is not being used at all. Obviously, these are not rechargeable batteries, so it's not being recharged. But first thing first, let me populate this with a video card, with some RAM. Let's make sure it works. I think it's a good idea. Alright, I got some RAM. I didn't need a video card. I didn't realize the Intel A10 is the first chipset with integrated graphics, apparently. So I got just a VGA out of the motherboard, power supply, and my post-analyzer card so you can see what happens. And let's try and power this up. Nope, it doesn't power up. Now, I do have 5 volt standby, so it should start up. Could it be one of those motherboards which don't like to start without a working battery? I mean, let's try that, because the battery, as we saw, is completely depleted. Let's try a new battery and see what happens. Right, okay, well, we definitely have a big problem here, because the battery is reading 1.8. I mean, it's a brand new battery. Yeah, 1.8, 1.9. Power supply switched off. I think there is a big short in here. Let me remove this battery. Maybe we don't need to power this up. Yeah, I mean, the battery, is reading 2.9. I'm assuming... oh, it's now 3.2. Okay. Right, so yeah, no, the battery is definitely working. I never had this before. I'm a bit confused. I want to try this again. If this is not reading 3.2, well, there's a big short somewhere. Yeah, 1.8. I mean, there's definitely a short somewhere, unless it's not making contact with ground. I guess I can check at the back real quick. No, it's 1.8 at the back as well, so it's nothing to do with ground. There's definitely a short somewhere, which we can probably see with a thermal camera. And if the battery is not able to provide enough current, we can probably try with my bench power supply. So let me show you something under the microscope first. Right, this is where the battery is, and here on the left-hand side is where the clear CMOS jumper is located. Well, there's definitely something there. Whether that is the cause of our problem, I don't know, but we might need to give it a clean and inspect. Can that cause a short? I don't know. That's definitely what I think is a short on that battery. I mean, to read 1.8, there's definitely something. That capacitor there, it doesn't look nice. Yeah, there is some corrosion here. The capacitor is half corroded. Is that going to be enough to cause trouble? I don't know. What I want to do next is to, again, check with the thermal camera, because if the battery is reading 1.8, chances are we might be able to see something clearly with a thermal camera. And failing that, maybe I can use my bench power supply to give a little bit more oomph, let's call it that way, hopefully without damaging stuff. Right, thermal camera is on. Let me plug the battery and let's quickly double check that we're still reading that 1.8 volts. Yeah, did I see 3.2 for a sec? Wait a sec, it was 1.8 and now it's gone to 3.2. What's going on here? Now, I haven't got the power supply on this time, I haven't got the RAM. I mean, now it's reading 1.8. I think in a moment it will go up to 3.2. I don't believe that this is a bad contact with the probes. There is something with this board. Now it's 1.8. And now it's 3.2. I did move the probe, fair enough. But it doesn't feel like, when it's bad contact, it always goes down to 1.8. No 1.5, 1.3, 0 point something. I mean, now it's reading 3.01 and I'm rubbing the probes. I mean, this cannot be bad contact. Something's happening. 3.1 instead of 3.2 is not going to warm anything on the board. My thermal camera is going to be useless, I guess. Right, I think now it's constantly a 1.8, but I'm unable to see anything on the board, which is, to be honest, it was kind of expected, as these batteries, obviously, they can't provide more than a few milliamps, I guess. And probably that is not enough to do anything. Let's see if it's still 1.8 volts. Yeah, it's 1.8. You know, I'm pushing it in and out, and still 1.7. It's definitely not a bad contact here. I mean, up to 100%. And again, it's 1.7, 1.8. The battery is not getting hot. Once again, they're very low power. I guess it doesn't help the battery. But no, I don't see anything, especially in the vicinity. I was hoping to see something in this area here, and there is absolutely nothing, not even a glimpse of something getting hot. Now, if I'm looking at these components, I'm reading 1.45 at this capacitor, and I think I'm reading the same, yeah, on the other end of this capacitor. So they are definitely involved with the voltage. Again, now the battery is providing 1.7. I can see 1.7 coming to this diode and out. Obviously, that's probably, so 1.7 looks like it's getting into this diode. Coming out at 1.4, so we have the 0.3 volts voltage drop for the diode itself. I see 1.45 getting into that, what looks like a damaged resistor, or anyways, pretty corroded resistor. I got 1.2 at this capacitor here. So obviously these components here are involved with the CMOS battery voltage. This one is 1.7. This is getting the full 1.7 from the battery. 1.7 again. And the jumper here, which is for normal operation, is 1.45. So I guess that's the voltage going to whatever is holding the information for the BIOS, or the information, the settings for this motherboard is going through this through this jumper here. Now, speaking of that jumper, I guess if the jumper is taking that voltage somewhere, what happens if I remove the jumper? Does the voltage go back to 3.2 volts? No, it doesn't. So again, without knowing too much about it, assuming that this is simply a jumper that goes to whatever is being energized by the battery, well, the issue is not with that side of the circuit, it should be within here, which is probably good news. Now, I guess this is not a dead short. If it was, it would read 0 volts or very close to 0 volts. So I don't think I can try and check for shorts with my multimeter. I have a feeling maybe my option would be to use my bench power supply, 3.0 volts, with some limitation on current, of course. I need to check online how much current 2032 can provide, and provide a similar or just a little bit more. And hopefully we can see something glowing on thermal camera. But let's check with the multimeter. You never know, you find something. I got my multimeter in diode mode. One probe is on ground, and I can check with that. This is ground, and would be the positive of the battery. It's reading 1.7 voltage drop. Now let's check these components around here. One is going to beep, of course. One can be ground. One is fine, but not both of them. What about that nasty looking capacitor here? 1.6 volts on one end and ground on the other. That nasty looking resistor, 1.6 on one end, 1.6 on the other one. These two diodes. They look fine. Let me try and see across those components if I can find something. Now, even the nasty capacitor is reading 1.7 volts of voltage drop. And the resistor is reading 5.7 kilo ohms, but I don't see anything too nasty. So I think my next step is the bench power supply. Let me find first how much current a coin battery like this can provide, so I can try and match the power supply to provide the same amount of current. Alright, I got my power supply set to 3.2 volts and at the moment 4-5 milliamps. I understand that the 2032 can do, say, up to 10 milliamps, but let's say short terms. It's not really designed to provide a kind of current. But let's begin with 4-5. I got my black probe connected to ground somewhere on the board and the plus where the plus of the battery should be. Let's turn on the power supply and see what happens. 3, 2, 1, go. No, that's totally fine. 3.2. We got 1 milliamp. So is there something wrong with my battery? And I'm assuming I'm reading 3.2 volts. Yeah, we got 3.2 volts. No issues whatsoever. So what's going on here? Maybe I have an issue with the battery and or an issue with the contacts here. Okay, I don't know what to think. I think I have a faulty battery. I can't think anything else. Let me try another. Let me get the battery from the Asus motherboard. That looked fine. I think this is fine. I think it was reading 3 volts. It wasn't 3.2. This is not brand new. I think I have either a faulty battery or a batch of faulty batteries. This is like 45 minutes, actually more than 45 minutes wasted. These are coming from eBay. They're not expired. It says somewhere here 2034, but chances are they're fake. And that's what happens when you buy stuff on eBay. This one out of the box is 3.3. Let's see what happens here. Well, so far so good. My gosh. And this is 1.8. I have a bad battery. All this time I have a bad battery. Seriously? This is weird. I never had anything like that. Yeah, this is reading 3.2. It's a bad battery. Brand new. Out of the box. Anyways, right, let's... I don't know how I'm gonna edit this one, because this is probably gonna be like 20 minutes for nothing. So we'll see what happens. Let me try and power up this board again. You never know this time it starts. Oh my gosh, seriously. Would you believe these? I mean, I've been playing with this battery for like 45 minutes. And it's just a bad battery. I can't believe that. I had something on screen, now it's gone away. I know, there it is. Yeah, we got boot failure. We don't care, it's working. You know. I mean, what are the chances that I'm working on a motherboard which has an issue with the CMOS battery being depleted? I open a new blister of Energizer and I get a bad battery that is reading 1.3 volts, 1.8 volts randomly. What are the chances? I'm going out. I think I'll buy a lottery ticket or something like that. Anyways, the motherboard works. Obviously, it needs a battery to start. And obviously, we don't have an issue with the battery voltage, at least not a massive issue as I thought we had. This is reading 3.2 volts, totally fine, board is working. Right, let's go back to plan A. Let's try and ascertain how much current a working motherboard is drawing from one of these batteries. Now, this is another brand new battery from the same blister, so is it gonna be good? I don't know, guess I'll like to check it. It reads 3.3 volts. What does it read when it's in the socket? Well, this seems to be apparently a good battery, 3.3 volts. Now, I made a little contraption here. It's a simple battery holder, which goes to 2 wires. I've got my Kaiwitz out because this is reading milliamps with quite some precision. Unfortunately, the Kaiwitz has this feature which it's understandable. It beeps all the time while taking current measurements. This is to remind the user that you're in current measurements. It makes sense. I have blown myself a multimeter in the past because I was reading current and then I forgot, and sometime later I went to read voltage and I blew up the multimeter. So it's very simple. The negative lead is going straight to ground on the board, and the positive is going through the kaiwits to the battery holder. So let's see what kind of current that we are reading if I wire the battery. Nothing. What do you mean nothing? It's impossible. I definitely have 3.3 volts at the battery holder. There is 0 milliamps. And again, this is 0.000 milliamps. I checked this before with a fan just to make sure, you know, everything was working, especially because it was beeping. I didn't really understand what was going on. Let me try a different motherboard. I don't know. This is the first time I'm doing it. This is a socket 462 motherboard, kind of modern, so not too old. It came with no battery. Let's try this again. 3, 2, 1, go. Oh yeah, we can see something here. Not much. It did do something, but yeah, it looks like it looks like the current read is so low that it's less than 0.000 milliamps. Wow, okay. Well, that would explain why these batteries are lasting for years, right? Of course, the battery doesn't last for months. It lasts for, I don't know, 5 years. I think 5 years is actually a safe assumption. This is what a healthy motherboard is reading. So let's go back to the Gigabyte motherboard and see what it reads. And I discovered something this afternoon when I started working again. I'll show you in a sec. And we are back to the Gigabyte, and what I discovered is that the brand new battery that I installed yesterday is already reading 2.8 volts, 2.9, yes. So either I have a bad batch of batteries, which is very possible considering one was definitely faulty, or this battery is being more or less depleted overnight. I'm not going to reuse this one. This is a brand new one, which again, as long as it reads 3.3 volts, it means it's fine. Let's try this new battery on this board and see what kind of current we are reading. Oh yes, that obviously got the polarity swapped, but that's fine. That clearly explains why the battery is being depleted on this board. We're reading 0.7 milliamps being drawn all the time. Let's see if by any chance, out of curiosity, whether the current goes to zero or almost zero when power is applied. I'm about to switch on the power supply, so that means 5 volt standby is going to the board. In 3, 2, 1, go. There we go. Yes, so there is a circuit, and I was totally expecting that, which is stopping using the battery as soon as the power supply is providing 5 volt standby to the board. It makes totally sense. But as soon as I switch off the power supply, and switching it off now, and I guess it will take a few seconds for 5 volt standby to deplete, it should go back to, there we go, 0.7 milliamps. That is great, because now I can diagnose this board, because we have 0.7 milliamps being drawn all the time. Perfect. Before we continue, a quick shout to the sponsor of this video, PCBWay. If you watch my videos, you will know PCBWay has been helping me with my project for quite some time. The very 8-bit ISA extension you've seen at the beginning of the video, well, it was designed by myself, and you can download the Gerber file for free from PCBWay store. There are two versions available, the 8-bit and the 16-bit, and both of them can be downloaded for free, the Gerber files, but you can also add them to a cart and basically ask PCBWay to manufacture them for you. Whether you need to order a PCB, a 3D print, or any of the other services from PCBWay, well, take a look at their website, PCBWay.com. It's very simple to use, and since you are there, you might want to take a look at the 8 design contest, which started in September and ends on the 31st of January, at least for the submissions of the project. If you have a cool project in your mind, you might want to submit your idea to PCBWay.com. An independent panelist will choose the winners, and just participating to the contest will give you 600 points, which are equivalent to a Raspberry Pico 2. So take a look at PCBWay.com, the link is also down below in the description, and let me thank PCBWay for sponsoring my videos on my channels, because they help make these videos possible. So thank you very much, PCBWay. Now let's continue with this Gigabyte board. The next step is to look at that little corrosion that we've seen under the microscope. And I think first thing I want to do is to clean the area. Second thing I want to do is to probe a bit better with the multimeter now that we know what we are expecting. I'm assuming it could be one of the capacitors, the SMD capacitors. It could be leaking a little bit, like partially shorted. I've seen that so many times, and it's going to be difficult to ascertain, of course, because the capacitor probably will work totally fine, but it might read a resistance which is lower than expected. Let's start tinkering with it and see where we are going. And no, that didn't help. We still have 0.7 milliamps being drawn. I had a look around trying to understand how the circuit works, and first thing I wanted to understand is where is this voltage going? And I know that in the past I thought that the BIOS battery was powering the BIOS, you know, that's what the name says, but that's not the case. Obviously it's not in there. There's something else that has a little bit of RAM inside, which is kept alive by the BIOS battery. And at first I thought it was this IC here, which is a Wimbund, it's a Super IO, I think it is. But anyway, no, I checked on the datasheet, there's nothing in there. What I did basically, I had the battery plugged in. Now the battery is reading 2.9, I don't care if it's kind of half depleted, it's fine. And I probed around and eventually I realized I was reading some voltage here. I have 2 volts, 2.1 volts here, and it's by the ICH. So I went online, I downloaded the datasheet for this ICH, and yes, the RTC and all the RAM for the settings is inside this IC. This IC is getting primary voltage from the power supply when the power supply is running, or is getting the VCC RTC for the real-time clock, and this is the little crystal that runs the RTC clock inside. And the datasheet actually has the schematics on how this thing works. So the voltage is going through these 2 diodes. Well, the battery's voltage is going through 1 diode, and the power supply voltage, I guess, is 5 volts standby, eventually going through some components and eventually into one of these diodes. And the output of the 2 diodes is going to the ICH, but the output of the battery is going through a 1 kilo ohm resistor as well. So I'm in resistance mode, and if I'm checking the resistance between the 2 cathodes of the diodes, I'm reading 1 kilo ohm, which is exactly what the datasheet says. Now the bottom diode, let's call it the power supply diode. The top diode is the battery diode. Now the cathode of the bottom diode is going straight to what I believe is VCC RTC. There you go. It says 1 ohm because my probes read 1 ohm when they're shorted, but that's direct continuity. And the top diode, which is the one from the battery, it should read 1 kilo ohm. And it is. So I was looking for 1 kilo ohm resistor, and I think I found this one just above the crystal. It's a 102 resistor, and one end it says 1 kilo ohm and the other end says continuity. So this is going through the voltage coming from the battery, and the one of the 2 ends, it's going to be complicated to show you, is going straight to the ICH, assuming again my black probe is on the input of the ICH. Now, I don't know how visible that is on camera, but there is some corrosion around here again. So once again, I'm wondering whether there might be some issues in there. That being said, I don't really think that that could be an issue with the resistor, especially if the resistor in question is reading correctly 1 kilo ohm. So maybe that's not really the problem. But again, if I looked again at the schematics, I do see that the voltage from the battery is going then to something called V-bias, which is just a reference voltage apparently, so probably it's not really doing much inside the chip, it's just there as a reference. But on that little schematic there is one capacitor which is going to ground, it's going between VCC RTC and ground. And if the capacitor is leaking a little bit, well, that could be our problem. So this little capacitor here, C395, is connected between VCC RTC and the other side, the other end should be ground. Yeah, and this should be a 1 microfarad capacitor. Yeah, I'm not sure how much you can see that, but it's 1.1 microfarad. So the capacitor seems to be okay. It's reading a 54 ohm of ESR, but it's an SMD in circuit. So again, it's reading 1 microfarad. I think it means that's the capacitor we're looking for. So I think I have a couple of options here. Option number 1, which is the worst case scenario, there's something wrong with the ICH. The ICH, for whatever reason, is drawing that extra little amount of current, and again, it doesn't affect the power supply, but the battery is being depleted pretty quickly, and probably there's nothing I can do about that. Option number 2, there is some corrosion, which is causing some havoc. Again, we'll take a look in a moment under the microscope. I might want to reflow and remove that corrosion, make sure there's no obvious damage. Option number 3, which is my favorite, is that C395 is slightly leaking just enough to cause havoc on the battery, but once again, the power supply won't care. Let's go under the microscope and take a look again at the area. I thought the corrosion was just there, but no, there is corrosion around the ICH. We'll take a look and we'll see what we can do about it. This is the Intel ICH, and this is the area where I was poking around. And yes, there is definitely some corrosion. This is the capacitor where I could see the voltage coming, and I think this is where the VCC RTC is coming. And looking at the datasheet, the pinout of the ICH, the pin for the VCC RTC is in this area here, so it makes sense it's here. That is the 1 kilo ohm resistor I was probing earlier on, and there is some corrosion around here. There's also some corrosion around here, but I don't know what that is. Let's take a closer look. This is where I was probing earlier on, the VCC RTC. Now I don't know whether the other end of the capacitor is ground. I didn't really check. It shouldn't be, according to the schematics. Ah, it is, actually, it is. So there is a further capacitor which is going to ground, and this is another candidate that if it's partially leaking a bit, it might be the one causing the havoc. What kind of resistance am I reading across the capacitor? Well, I'm reading 4 kilo ohms, but again, for 0.7 milliamps, probably I'm not going to read anything with my multimeter. That's the 1 kilo ohm resistor, and I don't know about this capacitor. It's definitely wired. Oh, that's the capacitor in between the VCC RTC and the crystal itself. It's in the schematics. It actually looks pretty bad. I mean, it's dark on one end. It looks burnt. I don't think that is our problem. That being said, we haven't really checked whether the clock is working, the RTC is working on this board. This is reading the usual 5 kilo ohms-ish, so I don't know. It could be good, it could be bad. These are all part of the RTC and the battery circuit, so it's definitely worth surely cleaning this. Like this capacitor here, for example, is it broken? Or does it have some dirt on top? Well, at least it's not broken, and this is the area under the 2 diodes, and this little one here is the capacitor that I'm suspecting. Let's clean this area, and then I guess I'll reflow the area with my small soldering tip. And no, we still read 0.7 milliamps, 0.6 or whereabouts. So that's not our problem. I would move straight away to those 2 capacitors. Let's see if we can identify the other one. I mean, this also seems to be reading 1 microfarad, like the other one. Again, it's in circuit, but I guess we can remove them. They are working, so they look like they're both reading 1 microfarad. Yeah, they more or less read identical, even though they don't look identical components, but you never know. Let's begin with one. First thing first, let me see whether I have a replacement. Alright, I do have the 1 microfarad capacitors, but these are the wrong size, the wrong package, as you can see. These are much smaller. I think these are 0402, and probably I need the 0805. So no, these are way too small. So I happen to have this 4.7 microfarad, 25 volts. These are 0805, and I think they are either the right size or very close. These are between a voltage like a rail and ground. They're like smoothing capacitors, put it that way. So I think 4.7 is going to be fine, but it should tell us whether that is the problem. So I'd like to go with that. I'll do 1 capacitor at a time, so we see what happens. Let's begin with 1. Nope, we still have 0.6 milliamps, so let's swap the other one, which should be a 1 microfarad this time. No, it's still happening. So it wasn't that capacitor either. Well, I guess the chances of me fixing this are getting slimmer and slimmer. Now, because my component tester here is still reading 1 microfarad across those capacitors, and I thought that one of those two capacitors was 1 microfarad, I thought, well, there must be another capacitor somewhere, which is 1 microfarad. I'm on VCC RTC, and I found this capacitor here, which is also on VCC RTC. So one end is on VCC RTC, and the other end should be on ground. Yes, so that is also on the line. So we have 3 capacitors, and I imagine that that is the 1 microfarad capacitor I've been looking for. Let's take it out, measure it, and again, I haven't got 1 microfarad, I'll go with 4.7. No, it's still reading 0.7 milliamps, so I'll have to think about this because I don't know what the next step is. I've now done a little bit of troubleshooting off camera, and I think I have a few things I'd like to try. Now, first thing first, I've noticed there is another capacitor which is on the output of the battery. It's C405 here. One end is directly connected to the battery, the other end is directly connected to ground. So this is another one we can check, but then I noticed that the output of the battery, not only does it go to this diode here, but it also goes to this resistor here, which happens to be a 1 kilo ohm resistor. And I can see that this end of the resistor goes to this little via here, so I thought I would follow that. And as you might imagine, that's taken quite some time. Now, that is the via that I mentioned, and you might be able to notice that the trace where this via is going is a little thicker than all the others. After all, it's carrying 3 volts from the battery, so wherever this is going, you don't want to have a lot of voltage drop, even though the current is very low. So following this trace, which is chunkier, so it's simpler to follow, it ends here. And this is one of the IDE connectors. And I spent probably half an hour on the other side looking for where this was going. And I was about to give up, and then I thought, let's have a look at the back. If I see some other via around here, which has a thicker trace than the others. And I found these on the other side of the IDE connector. I scraped a little bit of solder mask to bust them, and yes, indeed, there is continuity with the other side. I follow this trace, and it goes up here, up here, up here, up here, and eventually stops in this area here. And what's happening in this area here on the other side? Well, I have the Windbone chip, which is the one responsible, between other things, to the power up, I believe, and that would be probably why the board doesn't power up unless the battery is running. So I started buzzing the line from the other end of the 1 kilo ohm resistor to the Windbone chip, and I found this. There we go, it's reading 1 extra ohm, I guess that's the long trace, but it's going directly to the Windbone chip. And also, while I was probing around, I found this capacitor here, C121 maybe, which is directly connected to the same, let's call it VCC line. And the other end, once again, is connected to ground. So this is another capacitor that we might want to take a look at in case it's leaking to ground. So if my understanding is correct, the battery is powering the Windbone chip for powering up the board, but also powering the RTC into the ICH. So there are a few things that we can check now. The first thing is very simple. I'd like to understand which one of these ICs or areas of the board is responsible for drawing that excessive current. So I could either remove the 1 kilo ohm resistor and basically sever this section of the board, or disconnect the diode on one end and sever this area of the board. And this is what's going to tell me where the problem is. I would say, let me disconnect the diode. It's simpler, it's a through-hole component, and that is going to disconnect the RTC on this end of the board. We'll see whether the 0.7 milliamps are still there. With the RTC disconnected, so this is only the Windbone, let's see how much we are getting. We don't see anything. And let's double check that we have the 3 volts at the Windbone chip. Yes, I'm checking at that capacitor that I mentioned before. We have 3.18 volts. So the Windbone is being energized, but we don't see any current. So the issue is not that side of the board. And I guess it's also not this capacitor, because I think we have voltage at this capacitor now. We do. So it's not this capacitor, it's not the capacitor, it's not the Wimbund, it's not that side. It's 100% this side of the board, either the Intel components here, anything. Now, one thing that was suggested to me on Vogons, and thank you very much for everybody who tried to help me on Vogons when I posted about this board, is these diodes. Now, those two diodes are there basically to switch between battery power or power supply power. The power supply power is going to be a little bit higher than the battery power. So basically the diodes are preventing the voltages to go where they shouldn't go. The power supply voltage is not supposed to go back to the battery to charge it, and the battery voltage is not supposed to go back to wherever that power supply voltage is coming, where it shouldn't go. Now, if one of those diodes is leaky, as in it lets some voltage, some current where it shouldn't go, backwards basically, what can happen is, well, worst case scenario, if this diode, the battery diode, is broken, is shorted, for example, well, then my 3.3 volts is going to try and recharge the battery, which is not great. But if the other diode is leaky or even shorted, well then when there is no power supply, the battery will power the RTC in this direction, but the voltage will go backwards to, I don't know where it's going. Maybe chances are it's going to some other ICs, which are not designed supposed to be powered by a battery. So what I'm going to do now, I'm going to reconnect this diode and I'm going to disconnect the other one. Basically what happens is the battery power is always going to be used. There's never going to be any power supply voltage going to the RTC or wherever it's needed. And if that excessive current disappears, well, that's telling me that the diode is faulty and it just lets some current backwards where it shouldn't go. So let's do that. Oh, would you look at that? I think this is probably expected. This is an order of magnitude lower than before. The diode is probably slightly leaky. I don't see any other explanation. No, the other two motherboards were reading 0. But I don't know, it used to be 0.7 milliamps and now it's 0.011 milliamps. And it's going down, by the way. So this is so much better. Now, if I'm checking with my multimeter now, I should be able to read VCC RTC on the through-hole pad that I've just desoldered. Yeah, 3 volts. And obviously there's nothing on the other end of the diode. And I guess if I just push down the diode using my probe here, or my tweezers, maybe it gives me a little bit more control without shorting anything. It's going to be difficult to see, but I'm basically pushing down the diode, so I'm basically reestablishing that connection that we had before, and 0.7. So we have some voltage traveling backwards through that diode, which shouldn't happen, I think. It's the voltage was, the current was down to 0. Oh, I have a feeling this could be the minimum that the Kaiwits can read, and that's why the other boards were reading 0. Because it was probably 0.003, 4, or 5, but now this is also reading 0. Let me see if I have another one of those diodes. Here is the diode. Let's test it in diode mode. And I'm reading 0.3 volts, so that makes it a low voltage drop diode, which is expected in this application. You have a very low voltage from the battery, you don't want to waste too much voltage just to go across the diode. And what I'm reading the other way around, shouldn't read anything. 1.18. That's not nothing. Is this diode faulty? That means that the battery is able to go across the diode in the opposite direction because it's 3 volts. Wow, and we found our faulty components. Let me see if I have another similar diode that we can test as a comparison. Okay, I found these similar diodes with glass case. These are onsemi fast 200 milliamps, whatever. I mean, to be honest, the voltages here are very low, the currents are very low. This is not switching application, so a general purpose diode, but with a low voltage drop is what we need. What is this reading? This is reading 0.6 volts of voltage drop, so that's not great for our application. But what is this reading the other way around? Nothing. Of course, it's reading nothing. We got our faulty diode, I guess. This is a BAT41 Schottky diode. Okay, 350, yeah, that can work. It's a little, like half a volt higher. And then I have this one, it's another Schottky diode, it's a BAT85. Oh, perfect, 0.270, so this is even lower than the original one, and what am I reading the other way around? Of course I'm reading nothing. Amazing! Oh wow! Well, if I'm looking online, the BAT85 has a forward voltage of maximum 400 millivolts. So, I don't know, the point is the existing diode, I don't know what it is. It has a 2 on the body, and it could mean anything, to be honest. Let's try this one, to be honest, and see what happens. Chances are it's going to be totally fine. Actually, since I'm here, I just pulled out the leg of the battery diode. So what is it reading in diode mode? Well, it's reading 0.3 volts as the other one. And it's not reading anything in the other direction. So this seems to be fine. We don't need to replace this one. And it's just the other one. Okay, well, let's replace it and see what happens. Alright, what are we getting now? Yeah, we're getting what we were getting before. This seems to be working, and I guess all the voltages should be okay as before. So after the diode, which I haven't touched, we have 3 volts. Yeah, we have 3 volts at the diode I've replaced and nothing on the other end. Do we see voltage at the Wimbund? We do, 3.18. Yes, look, this is now reading 0. I think this is fixed. Oh my gosh, thank you guys at Vogons, because the idea came from them. What I'd like to do now is to put a fresh battery, assuming I don't get another bad battery from my batch here. Fresh battery, get into the BIOS, set the time, switch it off completely, leave it overnight, and check the following day whether, number 1, the battery is still alive, number 2, whether the RTC is still running. This battery is reading 3.3, so hopefully it's a good one. Let's turn on the board and let's set the clock. Oh, what's happening? More? Oh, because the power supply is disconnected. Oh, come on. The clock is set. Let's power cycle the computer and make sure that it retains it. So let me save it first. Yeah, so far so good. So the RTC works and survives a power cycle of about 30 seconds. Let's check tomorrow. 2 days have passed since the last segment. What do we read on the battery now? And we read 3.255. I think this is a win. On the first test, the battery went down to 2.8 volts overnight. So I think this is working. And by the way, this is the voltage drop across the diode that we've just installed, and it's only reading 100 millivolts, so this is totally fine for this application. Let's turn on the board and make sure that the date and time is still correct. Yes, it's November 9th and it's 6:35 in the evening, so it works totally fine. I know that Doom is not exactly the right software for testing this board, but this board came on my desk just for the battery problem, so I don't really want to do any stress tests or anything. I just wanted to show you it's working, and it's working. I've really enjoyed this repair. It was kind of a weird one. I was hoping for like a big short on the battery, something important, which is what seemed to happen at the beginning, but that was a false alarm. But when I realized it was only 7.7 milliamps, I thought, okay, I will never be able to diagnose this board. But it was so cool to trace all the places where the battery is going, and then eventually, thanks to my friends at Vogons, they gave me the idea of the diode, and indeed the diode it was. I really enjoyed this repair. If you did, as usual, I'd appreciate a thumb up down below, and also consider subscribing to this channel and my second channel if you like this kind of things. Don't forget I'm on Facebook and on Patreon. The links are down below in the description. There is a free tier on Patreon, so no excuses. But if you don't want to support me on Patreon, well, maybe you can buy me a coffee, and the link is also down below in the description. If you don't want to buy me a coffee, well, I hope you enjoyed the video. That's it for today. I hope you have a great day, and hope to see you soon here on my channels for my next videos. Thank you very much, and goodbye. Bye-bye.